All right, welcome to this your lesson on how do we work with area, volume, surface area, and lateral areas. So I'm gonna try to make this as short as possible. Okay, see this? This is what we call a rectangular prism. Okay. All right, and this is also, but this is a triangular prism. Okay, it's made out of triangles. This is made out of rectangles or squares. But if it was squares, then it's called a cube. Anyway, so volume in this case will be length times width times height, and volume is always measured in let's say if we have centimeters, it would be cubic centimeters because it's to the third power. And why is it to the third power? Well, if we have x times x times x, that's x to the third power. We have three different measures here and we're multiplying them, so we have three-dimensional space here. All right, it's a figure of three dimensions, so that's why we have cubic centimeters. All right, so now a funny thing here is that the formulas sometimes are given to you in a different format. For example, volume can also be expressed as capital B times H. What in the world is capital B? Capital B is the base of the, the area of the base. The area of the base. Wait, but if the area of the base is a rectangle, isn't this base, the area of a rectangle, length times width? Correct. So that basically this formula and this other formula are actually the same. All right. Now, if we go and look at the surface areas, let's continue with the volume. All right. So these are things that will be given to you on the regions. Okay. There is a reference sheet that has all the formulas. Now it is up to you to interpret those formulas and make sense of them in order to solve your problems. For example, here, volume of a what? Of a pyramid. This is the pyramid right here. Now the value of the pyramid is 1/3 the area of the base. Okay, and notice what the base is. The base is a rectangle or a square, whatever you want to call it. It's a rectangle, so the area of the base will be length times width. So it's the same thing. Volume is equal to 1/3 of the area of the base times the height. Length times width times height. Look, base area and height. All right then. Now the altitude. Okay, the altitude, the height. It goes from the vertex to the base. All right, and the height is always perpendicular to the base. Okay, in other words, 90-degree angles. All right then. Surface area. How do I find the surface area? What is surface area? Well, guys, surface area is nothing more than the sum of all the areas of the faces of the three-dimensional figure. For example, these are called lateral faces. Okay, so you add the area of the lateral face, which in this case I have 1, 2, 3, and 4. Okay, and then you take the area of the base and you add it to that. All right, so for a regular pyramid, in this case, the word regular will mean that all sides are congruent. All right, like the base, I guess they're congruent, and look at the triangles. Okay, they will be congruent as well. So the formula is area of the base plus 1/2 PS. What is PS? Well, P is the perimeter. S is the slant height. What is the slant height? Well, imagine that. Let's go back to this problem. This is the height coming from the inside of the pyramid. Okay, it's going like, if this is the pyramid like that, then that is the height. Slant height is like if you have a, let's see, hopefully I can do this. Let's say this is perpendicular, but if you tilt it like that, okay, the segment coming this way is called the slant height, because it's not really like this, it's actually slanted like this. Okay, makes sense? All right then, so that's what it is. So these formulas will be provided to you. Of course, there are some formulas that you really need to be acquainted with. All right, let's talk about the cylinder. Now notice something. The area of the cylinder is this, the volume. We've been talking about volume. The volume of the cylinder is still the area of the base times the height. The area of the base. Thing is that the area of the base is a circle, okay? So you have to find the area of the circle. All right, and then you have to times it by the height. Okay, so that is for volume. Now, the surface area is the area of all the components of the cylinder. And that's why I have this can of Pepsi just to do this, okay? I didn't have anything else. Let me zoom out so you could actually see this. All right, so the can of Pepsi is basically a cylinder, okay? A cylinder. Now let's see the components of the cylinder. This is a circle. And of course, I have some Pepsi inside, so I'm not gonna turn it upside down. But you see that there's another circle at the bottom. Okay, so the surface area will be this area right here, plus this area right here, plus the area around it. But wait, hold on a second. What is the area around this? What is the area? Well, that's why I have this paper right here. Look at what happens when I wrap the paper around the circle, okay? So that's what happens. Now let me unwrap it so I show you what the shape is. The shape around the circle is nothing more than a rectangle. See that? A rectangle. Okay, so, well, that you need to find the area of this rectangle. All right, so that means that I have to do, well, remember, the area of this rectangle. How do you find the area of the rectangle? Length times width. But because the rectangle is, okay, in the shape of a circle, what is the length of this? What is the length of this rectangle? Well, what is the length of the circle that it forms? The length is, well, how do I find the length? Is the circumference of the circle. So it is, how do I find the circumference of a circle? I think it's 2 times pi times r. Yeah, that is the circumference of a circle, 2 times pi r. All right, cool then. So now, let's see what's up. This is the circumference of the circle, 2 pi r. Okay? Now, the length of the rectangle is the circumference, the length, times the width. But the width is actually the height. See that? The width is the height. Oh, okay. So it's the circumference of the circle, which is 2 pi r. That is the circumference of the circle. Okay. Multiplied by the height, the width. And the width is the height. So whatever the height, okay. How can I put this? You know what? Let me not just write this down. Okay. So 2 times pi r times the height. That is the area of the rectangle. You see that? Plus the area of the two circles. How do I find the area of a circle? The area of a circle is pi r squared. But then again, we have two circles, so it's plus another pi r squared. Okay. Guess what? If we combine this pi r squared and pi r squared, we end up with 2 pi r squared. So then, you have to memorize that the surface area of a cylinder is the area of the rectangle, which is found by this, plus the two areas of the circles. All right? And anyway, you're going to have this reference sheet available to you, so you could just refer back and make sense of them, okay? All right, what else do I need? Okay, this is the reference sheet I was actually talking about. So you see, they give you the whole thing. So volume, and you have volume of a cylinder, pyramid, right circular cone. Okay, we will see that in a little while. The sphere. All right, watch this. The sphere is nothing more like the Earth. Okay, the Earth is a sphere. All right. Right circular cylinder is just a cylinder with a regular cylinder actually. Okay. Right circular cone. It's actually a cone like ice cream cone. Okay. And then again the sphere. So, but you see different things: surface area, lateral area, They talk about L, which is the slant height, which is the height that is not really perpendicular, but it's like the Pisa Tower in Italy, if you know what the Pisa Tower is. All right, so let's start cooking over here. All right, the first problem says, Tim has a rectangular prism with a length of 10 centimeters, a width of 2 centimeters, and an unknown height. He needs to build another rectangular prism with a length of 5 centimeters and the same height as the original prism. The volume of the two prisms will be the same. Find the width in centimeters of the new prism. They want me to find the width. First of all, a rectangular prism, they look like this. And then you connect the thingies, and you get a box. You like that, right? Okay, good. So then it says that the length here is 10, the width is 5. Let me see. Oh, I'm sorry, no, the width is 2. Okay, the width is 2. And the height is unknown, so I'm just gonna call it H. Then he wants to build another prism, okay? So, okay. He wants to build another prism with a length of 5 centimeters. So this is 5 centimeters, okay? And the same height. Okay, do I know the height? No, it says unknown, so I'm just gonna call it H. And this is the width, W. They didn't give me the width, that's what I need to find. All right, so what is it that I know? That both of them will have the same volume. So what does volume look like on this prism? Well, length times width times height, okay? And they say that both volumes should be equal. So then this is going to be equal to length times width times height. All right. So how in the world am I going to figure this out? Well, let's see. Let's do the rational thing. 10 times 2 is 20. So 20 times H, right? Makes sense? Yes. And here you have 5WH. All right. Now what else? What can I do? They want me to find W. Oh my God, look. If I divide by 5, H, if I divide by 5 and by H, guess what's going to happen? 20 divided by 5 is 4. H cancels out with H. Here, 5 cancels out with 4. That's the radiator, that's the heating system. And H cancels out. And that leaves you with W. Oh, good day. I found it. W is equal to 4. All right? So, let's move on to our next problemo. It says, a rectangular prism has a volume of 3x squared plus 18x plus 24. Its base has a length of x plus 2 and a width of 3. Which expression represents the height of the prism? Listen to me. I know that these are expressions, but let's reason coherently about the problem. The volume is, volume is nothing more than length times width times height, right? Okay, the volume is already given to you. 3x squared, all right, plus 18x plus 24, okay? This is the volume, and that equals to length times width times height. So the length is x plus 2. Make sure you put it in parentheses, okay? And a width of 3, okay? But then they're not giving me the height. They actually ask me what expressions represents the height. Okay, so we know that volume is length times width times height. Okay, that's what I know. Remember, you know what? I'm gonna give you an analogy right now. Okay, 6 is equal to 3 times 2. 3 times 2 is 6. Okay, now how do I get, mixing these two numbers right here, how do I get 2? 6 divided by 3 is 2. Oh, okay. What about this one? 6 divided by 2 is 3. Oh, okay. So when I want to find out one of the other numbers, instead of multiplying, I'm going to divide. Because to get 6, I multiplied. So to get one of the other numbers, I'm going to divide. So that is the analogy. So then what am I going to do? I'm going to divide. I'm going to solve for h, right? I don't want you to think of it as an equation. I want you to think of it as a real world problem. So I'm going to divide by this. Okay, I'm going to divide h by this. Okay. So divide by x plus 2 on both sides times 3. Okay. Divide by x plus 2 times 3. Okay. So this cancels out, and that leaves you with 3x squared plus 18x plus 24 over x plus 2 times 3. I'm going to put the 3 right here. And that is equal to the height. All right, still this doesn't look anything like any of the choices. Guess what? I'm going to tell you, I'm going to let you in a secret. They gave you an expression. This is a polynomial. Right away, when they give you something of this nature, like square or whatever, that means that you are going to have to factor this out. Oh, okay. That's basically what it is. The purpose, the main idea of this problem was not to find the height or the width or the length. The main purpose, what they wanted you to do here is basically use the geometry problem to ask you to make you factor. Okay? All right, so let's factor this out. When you're going to factor, the first thing you do is you find the greatest common factor. Okay? What is the greatest common factor between 3, 18, and 24? Is 3. Then when you factor out, what you got left? X squared plus, okay, you factor out 3, so then you got 6. Because 3 times 6 is 18. So 6x plus 4. Okay, good. Now that is divided by 3 times x plus 2. Notice that I'm not multiplying. I'm not using the distributive property. Why? Because this looks like some type of factored form. So then I'm going to look for the same thing on top. All right, so let us continue. Let us factor x squared plus 6x plus 4. So the 3 is right here. So we got that. All right, factors of x squared, x and x. Two numbers that multiply give you, wait. 3 times, this is now 4. This is 24, so this is 8. 3 times 8 is 24. Okay. Two numbers that multiply give you 8, and when you add them, you get 6. 4 and 2. All right. Now you need positive 6. Okay. 4 plus 2. Oh, nice. And 4 times 2 is 8. Over 3 times x plus 2. And now I'm ready. Now I can see it. Now I can cancel out. So cancel out the x plus 2, cancel out the 3, and you end up with x plus 4. So the height of the prism can be represented by x plus 4. See that? That wasn't difficult. All right, let us continue with the next problem. Here, this is what we call a triangular prism. All right? A packing carton in the shape of a triangular prism is shown in the diagram below. What is the volume in cubic inches of this carton? Well, guess what? A triangle, as I said before, it's like half of a square. Let's put it like that. So then a triangle, the area of a triangle is half the area of the square. Okay, why am I saying this? Well, because you need length times width times height. The volume, I'm going to give you a different word for volume. When you find the volume, it's like you find the area of the base times the height. Volume is always the area of the base times the height. This is infallible. This is not is flawless. It's not up to corrections. It is what it is. Capital B stands for the area of the base. Okay. In a triangular prism, the bases are the triangles. All right, cool then. So let's find the area of the base. So base, remember, is length times width. In a triangle, it's base times height divided by 2 because it's half of the square. So let's see. The base is 6. All right, I'm gonna put it right here. 6 times the height is 4, okay? 6 times 4 is 24. Now guess what? The area of the triangle is not length times width, it's length times width divided by 2. So in other words, the area of this triangle is 12. 12 what? 12 square inches. Now we got the area of the base. In other words, we got length times width. Now we're gonna multiply this by the height, which is 10. Make sense? Okay, I know it doesn't look like a height, but this will be the height. Okay then, so now, length times width times height, 12 times 10 is 120. And that, my friend, gives you the solution to your problem. All right, fine, let's continue with this. All right, so the next problem says, the volume of a rectangular prism is 144 cubic inches. Wait, they're giving me the volume, so right away, of volume, I know what volume is. Volume is length times width times height, okay? Or a different way of putting it is the area of the base, which is length times width, times the height. I don't know, whichever way you want to call it, it really is, it makes no difference. All right, so the volume of the rectangular prism is 144 cubic inches. Okay, the height of the prism is 8 inches. But you see how I lay out the formula? Because it's very important. And now all I have to do is put everything into place. The height of the prism is 8. So height is 8. Okay. Which measurements in inches could be the dimensions of the base? So you have these measurements. So all you gotta do is basically dimensions of the base. That means that the area of the base. Okay, so you multiply this by this, and then you multiply it by 8, and that should give you the volume of 144. So which of these should be the dimensions of the base? Answer it. Right, because 2.5 times 7.2 times 8 give you 144. All right. The packing company, needs a rectangular shipping box, right? The box must have a length of 11 inches and a width of 8 inches. Find to the nearest tenth of an inch the minimum height of the box such that the volume is at least 800 cubic inches. All right, so what do I know? That length times width times height equals to the volume. Oh, okay. Look, the length is 11. So right away, you go down the length and you put 11 times. The width is 8. Okay, 8. Find to the nearest tenth of an inch the minimum height. Guess what? I don't know the height, so times h. Okay? Now, so that the box, the volume is at least 800 cubic inches. Guess what? At least, this is not an equation. At least means that the volume should be that or more. So it's going to be greater than or equal to 800 cubic inches. Okay, so 11 times 8 is 88. Times h is 88h. Now I'm going to what? I need the height. So what am I going to do with this 88? Good. And then I get that the height must be greater than or equal to 9.090. But it says to the nearest tenth of an inch. So then the height should be greater than 9.1. As simple as that. Okay, let's continue with this. A regular pyramid with a square base is shown in the diagram below. So this is the pyramid and this is the square base. Okay. A side S of the base of the pyramid is 12 meters. So the side is 12 meters. What else? And the height H is 42. The height H, the height of the pyramid. Okay. So the height right here is 42. Okay, so I'm just going to put it 42. Okay. What is the volume of the pyramid in cubic meters? The volume of the pyramid. All right. How do I find volume? Well, volume is length times width times height. Or volume is the area of the base times the height, whichever you want to do. Okay, I am going to use this one. I like this one better because it has less letters. So the area of the base. What is the base? The base is a square. It says it right here. You need to read the question. So the base is a square. Ah, okay, because it says it right here, right? So if this is 12, this is 12, this is 12, this is 12. I'm not going to add them because I'm not finding perimeter. I'm going to find the area of the base. So how do I find the area of the base? Easy. The area of a square is side square. You take the side and you square it. What do you mean? Well, you could do length times width. Length times width. So 12 times 12 is 144. So, okay, so the volume here is going to be 144 times the height. All right. But I know what the height is. Oh, I know the height is 42. So then, guess what? Instead of H, I write 42. Cool. Now, the volume becomes 144 times 42. Which is what? 6,048. So I found my volume. Would you agree? Answer me. Of course not. Why? Because this is a pyramid and we know that we can fit 3 pyramids inside a rectangular prism. Oh, so then I gotta divide by 3. Yes, you gotta divide by 3. And when you divide by 3, your volume becomes 2016. As simple as that. Get it? Good. Let's go on to the next problem. The base of a pyramid is a rectangle. Okay, we already know that. Okay, cool. With a width of 6 centimeters and a length of 8 centimeters. Find in centimeters the height of the pyramid if the volume is 288 cubic centimeters. Okay, to find volume, we multiply the area of the base times the height. And we already know what the area of the base is. It's a rectangle, so it's going to be length times width. All right, cool. Remember, they are giving you the whole volume, so therefore you're going to be dividing by something. When they want volume, then you multiply length times width times height, or the area of the base times the height. Okay then, so volume. What is the volume? 288. Cool then, so we put 288 here. Okay, equals. And now what is the area of the base? Well, the base is a rectangle, so it's going to be length times width, 8 times 6, times height. Do I know the height? Of course not. That's what they're asking me for. Don't be dumb. Oh, I'm sorry, my bad. Okay, so that's what I have. Guess what? You have 288 equaling 48 times the height. Wait, hold on a second. This is a pyramid. Oh my God. The volume of a pyramid is not just the area of the base times the height. The volume of a pyramid is 1/3 the area of the base times the height. And if you want to rewrite this, it's nothing more than the area of the base times the height divided by 3. Ah, nice, right? Cool then. So what does this tell me? This tells me that length times width times height, the area of the base times the height, has to be divided by 3. So that means that I have to divide this by 3. Ah, thank God you already memorized these formulas. Okay then, so 288 equals, what is 48 divided by 3? 16. So it's equal to 16H. Oh, my man. Oh, you're nice. Yes, yes, yes. I've been saying that all along. And now we need H, right? So 16 times H is 288. So 288 divided by 16 should give us H. Oh my God. You are too much, Becca. Now what is 288 divided by 16? That's 18. You see how looking at the problem and remembering what type of solid you're dealing with helps you solve the problem? All right, good. Move on to the next problem. Wait. Okay, now we can continue. Okay, can I zoom in this? Can I zoom in? Can I? Oh no, it becomes blurry. Not blurry anymore. Okay, good. It says, a right circular cylinder has a volume of 1,000 cubic inches and a height of 8 inches. First of all, right away, it says has a volume. So that means that length times width times height is already given to you right here, the whole volume. So what's next from there? You're going to divide. At some point, you're going to divide because you already got the volume. All right. So a right cylinder. First of all, let me draw a right cylinder. Something like this. Remember, it's a right cylinder. This is the radius, okay? And it's gonna go down. Okay, so let me put this down. Let me put this down. Okay, close it like this. Ah, nice. And now I am going to do my magic. I'm trying to make it look like a cylinder. Hopefully it looks like a cylinder. Okay then. So, a right cylinder, cool. It has a volume of 1,000. Okay, so the volume, remember what the volume is? The volume is the area of the base times the height. Now, why the area of the base times the height instead of length times width times height? Because of this. Look at this. We're dealing with a cylinder. So I don't want to be saying, oh, length is going to be 2 pi r. No. The area of the base. Okay, cool. So the volume is already 1,000. Make sense? Yes. Now, it has a height of 8 inches. So this height right here, okay, is 8 inches. What is the radius of the cylinder to the nearest tenth of an inch? I don't know. How am I going to do that? Oh, they want the radius. Okay, so area of the base. What is the base? A circle. So what is the formula to find the area of a circle? Pi r squared. Okay. And now remember, the area of the base times the height will give you the volume. So pi r squared times height times 8. Make sense? This is the height. Oh, okay. Now what? What do you mean now what? They want the radius. Okay then. So what am I gonna do? Easy. 1,000. I'm gonna divide by everything I don't need. Remember, to get volume, you have to multiply this. Well, to get one of these, you're gonna have to divide everything by 1,000. So I'm gonna divide by 8 pi. I'm gonna divide by 8 pi. Make sense? Yes. Okay then. So what happens? Pi cancels out. 8 cancels out. Now, what is 1,000 over 8 pi? Well, that is 1,000 over 8 times 3.14. Okay? And that, my friend, is equal to r squared. Now, what is 1,000 divided by 8 times 3.14? Well, figure it out. Let's see. 1,000. 1,000. Okay. Oh, no. First I need to do, okay, divided by, and then I do 8 times. You see how I put it in parentheses? I'm telling it to divide by the whole thing, because if I don't put parentheses, it's going to divide by 8, and then it's going to divide by pi, and that's not what we want. So 8 times pi. And close parentheses, and boom. That's what we get. 39.7887. Oh my God, too nice. All right, then, so I write it right here. By the way, this is r squared, remember? From here. Okay, so I have 39.7887. I'm just gonna stop there. Being equal to the radius squared. Guess what? They want the length of the radius. They don't want radius squared. So how do I undo this squaring? Yes, whoever said it, you're right. Take the square root of that. And what is the square root of r squared? R. And what is the square root of 39.7878? 6 point, let me see, I don't want to make a mistake. So the square root, okay, the square root of that is going to be 6.307. Guess what? They want it to the nearest tenth. This is the nearest tenth. This is a 0. You do not round this one off, so it stays at 6.3. And that's it. That's your radius. Getting the hang of this? Yes. Okay, good then. So now, let us do the next problem. All right. Let me make this a little smaller, more smaller, more smaller. I think that's good enough. Yes. All right then. So, which expression represents the volume in cubic centimeters of the cylinder represented in the diagram below? Okay, I want the volume. So, how do I know, what do I know about volume? Volume is length times width times height, if you want to do it one way. If you want to do it my way, it's just the base of the area. The area of the base, you know what? Don't laugh at me. Don't laugh at me. Okay. The area of the base times the height, that's volume. All right, so let's find the area of the base. What is the area of the base? The base, okay. Well, volume equals, the base is a circle. So pi r squared, that's the area of the base, and then we're going to multiply by the height. Okay. So what is the radius? The diameter is 12, so don't get confused, okay? Don't play around. The diameter is 12, so the radius is 6. Oh, okay. So volume equals to, let me see, pi times 6 squared times the height, which is 27. Now, guess what? Why didn't Becker, why didn't you turn this pi into 3.14? Because I was looking at the choices right here, and they are all in terms of pi. Oh, okay, thank you. So volume equals to 6 squared is 36. So it's 36 pi times 27. And 36 times 27 is what? 972. So volume equals 972 pi. And there you go. That's how you do it. My man, you are too nice. Okie dokie. Let us go on to the next problem. Let me see. Okay. It says a right circular cylinder has an altitude of 11 feet and a radius of 5. Okay, so I like to do my diagram. So I go like this. Okay. Then this is going to be like that. Close it like that. Okay, and that's your cylinder. Look better than the other one. Okay, so the altitude is 11. The radius is 5. What is the lateral area? Guys, lateral means the side area. So the side area is basically the rectangle. Oh, okay. So what am I going to do? Nothing, just find the area of the rectangle. Remember how to find the area of the rectangle? Easy. The area of a rectangle is length times width. But in this case, the length of the rectangle creates a circle, just like this. This is a rectangle and it creates a circle. So how do I find the length of this circle? Easy. the length of the circle is 2 pi r. Or if you, or d pi. What does d stand for? D stands for diameter. Okay, whatever you call it, beker, it doesn't matter. So then, this is the length. But to find the area, the lateral area, the area of the rectangle, we gotta do the length of that times the width, which in this case, the width becomes the height, so it's 11. Oh, okay. So now we could work around it. So let's do this. So 2, okay, let me separate this. 2 times pi times r. What is r in this case? What is the radius of this cylinder? It's 5, right? Nice, beker. You abyss. Okay. So now I'm gonna multiply that by the height, which is 11. Okay. So what do I have? 2 times 5 is 10. So it's 10 pi times 11. And what is 10 times 11? That's 110, I think. No, something is wrong here. 10, let me see. 2 times 5 is 10. Right. Oh, my bad. I was thinking about something else. All right. 10 times 11 is 120. So 110, sorry. So this is 110 pi. All right. But guess what? Look at the choices. None of the choices are in terms of pi. In terms of pi. So basically, you have to turn pi into 3.14. Okay. So then let's multiply 110 times pi. Boom. Okay. We got that. So let's see. 110 times pi. Where is pi? I cannot find pi. I found pi. And that is 345.57. Oh. So this is roughly, okay, 110 times 3.14 is roughly 345.57. It says to the nearest tenth. Guess what? This is the 10th. What is the next number? A 7. So should I round this 5? Of course. If it's 5 or more, you round it. So in reality, your answer is 345.6. Guess what? They give it to you right here. Look, 300. Choice number 3 is 345.4. Choice number 4 is 345.6. You have to know how to round in order to get the correct response. Get it? Good then. All right, let's go on to the next problem. Okay, it says a right circular cylinder has an altitude of 11 feet. Okay, so this altitude is 11. All right, and a radius of 5 feet. Okay, so the radius comes from the center of the circle to a point on the circle. We've seen that, and it's 5 feet. Okay, feet. All right, and what is the lateral area in square feet? Well, they're talking about area, so it's gonna have to be square units. In square feet of the cylinder to the nearest tenth. All right. So let's see how I approach this problem. So we know that the radius is 5, okay, and we know that the height is 11. So let's figure out how to find the lateral area. So I'm gonna refer back to my little formula right here. So it says lateral area, you see that, of a right circular cylinder is 2 pi r times h. That means that I just need the area of the rectangle right here, okay, when I unwrap this. That's why it's, so lateral area equals 2 pi r times h. 2 pi r is the length of the rectangle, and the width is represented by height. Get it? Length times width. Okay, so that's all I gotta do. So let's see now, how do I do this? Gosh, and I don't have the calculator with me. Well, I'll go get it. 2 times pi times the radius, which is 5, hello, and then times the height, which is 11. Now, what is that? Well, if you have calculators, you better get to work on that because I don't have mine. I'm gonna go get it. I'm gonna break it. No, I don't wanna break it. Oosh. All right. So Next time, beker, be prepared instead of making all this mess. All right, cool then. So I'm ready. So I'm gonna calculate it. So what am I gonna do? I'm gonna put it right here. All right, so I'll put 2 second the caret symbol right here. Okay, right here. See that? Okay, second, and that gives you pi. Okay, times 5 times 11, and that gives you 345. LA is 345.575. Okay, so on and so forth. Alright, so now I'm supposed to do what? I'm supposed to round to the nearest tenth. Okay, so it will be 345.5. That rounds to 346. Right? Sorry, no. It rounds to 300 and it says to the nearest tenth. Okay, 345.6. Sorry, my bad. So the answer is choice number 4. Oh, okay. That wasn't bad. Okie dokie. So let's do the next problem. Okay. What is the volume in cubic centimeters of a cylinder that has a height of 15 and a diameter of 12 centimeters? Well, cubic, let me see, cylinder. So let's do the cylinder. And good thing, look what we have here in the back of the paper. We have another cylinder, so it's easier for me to just trace it. Okay, so trace it. Okay, and that is your cylinder. And now the height is 15 centimeters, a diameter of 12. So this diameter is 12. So the whole thing is 12. That means that the radius is 6. Okay, and now the volume of a cylinder. Well, how do I find the volume of a cylinder? The area of the base times height, correct? Sure then. So then, let's calculate the area of the base. The area of the base is nothing more than the area of the circle. Okay, and how do I find the area of a circle? Pi r square, okay? And then of course we do times the height. Alright? So then, start writing it down, substitute. Alright. So I just closed the door and I can continue. Oh my god, I moved it. Sorry. Oh, okay. So let's continue with this. So the radius is 6, so then I know that this is gonna be pi times 6 squared, which is 36 pi, times the height, which is 15. Okay, so now we just do the calculation. So what is 36 pi times 15? Well, let's figure out right here. Okay, so what is it again? It's 36 pi. Let me see, where is it? Oh, right here. Okay, 36 pi times 15. And boom. Okay, so, oh, wait. I don't have to do that. Look, all the choices are in terms of pi. Oh, okay, so I'm just gonna multiply 36 times 15. Okay, 36 times 15 is 540. Okay, so this is 540 pi. Okay, they didn't want me to multiply by 3.14. So the right answer is choice number 2. Okay, good then. Let's move on to the next problem, okay? So this is a worthy problem, but guess what? It's not impossible. So a paint can is in the shape of a right singular cylinder. The volume of the paint can is, okay, a can. So I'm gonna have to do the can. Okay, wakata, ta 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 ta, and that is my little cylinder. All right. So Now, right singular cylinder, so this is right, so boom, okay. The volume is 600, okay, so volume is equal to 600 pi. All right, so far so good. Then it says the altitude is 12 inches, so this is 12 inches. Altitude means height, okay. What else? Find the radius in inches of the base of paint of what the paint can. Express the answer in simplest radical form. Find to the nearest tenth of a square inch the lateral area of the paint can. Oh gosh. Okay. So first, let's find the radius. Now, how do I find the radius? Well, I need a formula that involves the radius. Well, guess what? The volume, if I'm not mistaken, of a cylinder is the area of the base, which is pi r squared, which is basically the area of a circle, times height. All right? So now, let's see if I can solve. Do I have the volume? Yes. The volume is 600 pi. Okay, so far so good. This is a number, so it's okay. I got it. Now, the radius is what I don't have. Okay, I don't have the radius. Times the height. The height is 12. Okay, wow, I'm using my brains here. All right, so let's solve for r. So pi is multiplying r, so I'm going to divide by pi. Guess what? 12 is also multiplying, so I'm going to divide by 12. So then what am I dividing by? I'm dividing by 12 pi. Okay? So my remaining formula, whatever equation, is the following. So I have 600 divided by 12. So let's divide 600 by 12. That is 50. So 600 divided by 12 is 50. Guess what? The pi's cancel out. And that equals to r squared. Because the pi canceled, the 12 canceled. All right, so far so good. Guess what? I don't want radius squared. They are asking me for the measure of the radius. So let's undo the operation squaring by taking the square root. Now, I want to leave this in radical form, because that's what it says, in simplest radical form. Okay, so not a problem. Okay, what else? Okay. Alright. So this is nothing more than you find two factors, one having a perfect square root, the other one don't. So 25 times 2 is 50. Okay. Now simplify. Square root of 25 is 5, and then this is radical 2. Perfect. So now I found r, the radius. Alright. So now they want me to find what? Okay, express the answer in simplest radical form. Now find to the nearest tenth of a square inch the lateral area. Okay, the lateral area. How do I find the lateral area of a cylinder? Well, you go back to your reference sheet, okay? And you figure out that the lateral area is nothing more than the area of the rectangle that is formed, the one that wraps around the can. Okay, so the lateral area of a cylinder is nothing more than the area of the rectangle. But the rectangle makes a circle, so it's the length, which is, what is the length when it forms a circle? 2 pi r times width, which is the height. Okay, so this would be 2 times pi times r, which in this case is 5 radical 2, times the height, which is 12. Make sense? Alright then, so when you multiply all this, you get roughly 533.1. Good? Okay then, so that's your lateral area, and this is a 4-point question, and you just got it. Alright, let's move on to the next problem, okay? Okay, so let's read it first and then I zoom out so you could see what I'm doing. So they have a cylindrical tank right here. Okay, they have the measures right here. The tank is open at the top. The tank is open at the top. Think about that. Okay, and the bottom does not need to be painted. So I'm not gonna paint the bottom, and it's open, so I don't need to put paint in any of this. All right, fine then. Only the outside needs to be painted. Yes, the lateral area, the one that forms the rectangle. Okay, each can of paint covers 6 square feet. Okay, so that's good information. So you highlight it. If you want a highlighter, I can provide you with one. If you're not my student, find a highlighter. All right. So how many cans of paint must be purchased to complete the job? Psh, beats me. I have no idea. But guess what? Since I never have the answers in front of me, we're gonna figure it out. All right. So I need the lateral area. And how do I find the lateral area of a cylinder? Easy. It's nothing more than the area of the rectangle. But when the rectangle forms a circle, then the length becomes the circumference, 2 pi r, and the width is the height. All right, so far so good. Guess what? Let's do this. 2 pi times the radius, in this case 12, okay? Yes, 12. All right. So now what? 12 times the radius, which is 12, okay, so far so good, times the height. The height is 22, okay, 22. Now let us multiply that. And when we multiply, we get, okay, wait, hold on a second. I don't know what I get when I multiply this. 1,659. Oh, okay. So the lateral area is 1,659. Now, you don't believe me? Let's do it over here. Okay, so let's do it. So I have 2 pi, okay, times 12 times 22, and that gives you bada bim bada boom bada bam, 1658.7, which basically I was supposed to round, okay, to the nearest what? Top, okay. How many cans of paint must be purchased to complete the job? All right, so I could leave this as 16,1658.7, and you know what? I'm gonna do it like that because I don't see anything telling me below the tank is will be up. It doesn't say anything to the nearest something, so 1,658.76. Okay. All right then. So now, what else do I know? Well, look at what it says. It says that each can of paint covers 600 square feet. How many cans do I need? Well, this is the lateral area. So then I'm gonna have to divide by this in order to figure out how many cans. Okay, this area divided by 600. So I get, where am I gonna do it? 1658.76 over 600. Okay, so I'm gonna divide that over 600 and we get 2.76. okay, so this is 2.76. Funny thing is that you're not gonna go somewhere and purchase 2.76 cans of paint. So then the correct answer is approximately 3 cans. Okay, 3 cans are needed, and that's it. Nice. Okay. Ta-da. Spot focus. Auto. Ta-da. Good. All right, let's go over here. It says a cylinder has a height of 7 centimeters and a base with a diameter of 10 centimeters. My God, this is so freaking difficult here. All right, so determine the volume in cubic centimeters of the cylinder in terms of pi. All right, so you draw a cylinder. Okay, and now we have the height is 7, the base with a diameter of 10, so the diameter is 10, that means that the radius is 5. Makes sense? And now determine the volume. Well, what is the volume of a cylinder? Remember, the area of the base, which in this case is a circle, so it's pi r square, right? Sorry, pi r square times the height. Length times width times height, area of the base times height, it doesn't matter. So times the height. So that is the volume. Cool then. B equals So let's do this. So the volume equals, right, pi times the radius, which in this case is 5, then you square it, and then you multiply by the height. Now you end up with the volume being equal to 25 pi, because 5 squared is 25, times 7. Alright, so now I multiplied 25 and 7. So when you multiply 25 times 7, which is actually very easy, because just think of quarters. Okay, times 7, which is 175. So I get 175 pi. Because he says, determine the volume of the cylinder in terms of pi. That's why I leave it in terms of pi. Okay, this one says, the volume of a cylinder is 12,566.4 cubic centimeters. Okay, now the height of the cylinder is 8 centimeters. Find the radius of the cylinder to the nearest tenth of a centimeter. All right then, so we need to find the radius. And they are giving me the volume, so I'm going to use the volume formula. So volume equals of a cylinder is the area of, oh my god, what is, oh, I know. It's the area of the base times the height. And what is the area of the base? The area of the base, basically the base is a circle. So it's 2, you see I don't even need to draw the cylinder. But anyway, so 2, no. The area of the base is the circle. So it's pi r squared times the height. Alright, so how do I do this? Well, let's see. Point 4, okay. Wow, I really separated these things. Okay, anyways, it's 12,566, okay? And then equaling to pi r squared, wait. Oh, I don't know what r is, okay, times the height. Now, what is the height? 8. All right, cool then. So now I can solve for r. Remember, you want r, and everything else is multiplying. So I'm just going to apply the inverse operation, which is dividing. So I'm going to divide by 8, and I'm going to divide by pi. So I'm going to divide by 8 pi. And what I do to one side, I do to the other. So I divide by 8 pi. See that? Then I get r squared equaling, okay, wow. Equaling, let me go up here. All right, r squared equals 12,566.4 divided by 8 pi, which is approximately oh my god, I don't know what it is. Okay, so I'm just gonna have to use the calculator. So let me see now. 12,566.4 divided by 8 pi. Okay, that's what I have here. Boom, see that? I press enter and I get 4,934.81. Okay, so r squared equals to 4,934.81374. Guess what? You have, okay, this is 4,000, just in case you ask. Now you have r squared, but you need r, so you're gonna have to take the square root of that. Okay, so what is the square root of that? $22.4. There you go. All right, so there you have it. That's your problem right there. That's how you find the radius. All right, let's go on to the next problem. And let me zoom out on that problem. All right. All right, it looks small, but okay. So in the diagram below, a right circular cone has a diameter of 8 inches and a height of 12 inches. Okay, we have it right here. So what is the volume of the cone to the nearest cubic inch? Okay, how do I find the volume of a cone? Well, volume equals 1/3 pi r squared times the height. Once again, the volume of a cone is nothing more than 1/3 the area of the base times the height. And oh my god, what kind of information do I have here? All right, so volume, let me see. Volume equals, let me see if I can zoom in a little more. Okay, right here. So it's 1/3 of pi times the radius. Okay, what is the radius? Well, if the diameter is 8 inches, then the radius is 4. Okay, 4 squared times the height. The height is 12 inches. All right, so let's see what this is. To the nearest cubic inch. Okay, so I just have to put it on the calculator. So I'll put it on the calculator. Let me see that. Clear. So to put fractions on the calculator, you press alpha, y equals, and you press enter. So that gives you a fraction. All right, so it is 1/3. Okay, times pi times the radius, which is 4 square, times the height, which is 12. Boom. So you get 201.06. Okay, so this is 201.06. Now if we round to the nearest cubic inch, then we have that this is nothing more than, these little things means estimate. Okay, an estimated of 201, and there you have it. Boom. Answer, choice number 1. All right. Let's do the next problem. So once again, a right circular cone has a base with radius of 15 and a vertical height of 20. Okay, so you know what? Yeah, let me draw a visual just in case. So this is your circular cone. So this is something like this. Okay, now guess what? This is, even though it's upside down, this is the base. Okay, because you're not gonna have it like this. All right. So a radius of 15. So this is the radius, and it's 15. Okay, then a vertical height of 20 centimeters. This is vertical height, or if you want to go from here like this. Okay, that's why it's called a right circular cone, because it makes a right triangle. All right, so the height is 20 centimeters. Okay, and a slant height of 25. This is the slant height. Okay, the sides is slant height, so the slant height is 25. Find in terms of pi the number of square centimeters in the lateral area of the cone. The lateral area is the one wrapping it around. Not a problem. So how am I gonna do that? Well, what is the lateral area of a cone? Let me see. Lateral area of a cone is pi times r times L. Okay, so let us just substitute. So lateral area equals pi times 15 times 25. Okay, and that is going to give us 375 pi. Okay, just multiply 15 times 25, and since they want it in terms of pi, you don't change the pi to 3.14, just leave it like that. All right, next problem. If the surface area of a sphere is represented by 144 pi, what is the volume in terms of pi? Well, I need to find what the volume of a sphere is. So look on the reference sheet and you will see that the volume of a sphere is 4/3 pi r to the third. So volume is 4/3 pi r to the third. And now I just substitute. All right. Wait, something is not right. I have the surface area is represented by this, but they want the volume. Oh gosh. Okay, let's figure out what the surface area is. The surface area of a sphere is nothing more than 4 pi r squared. So I don't have the radius, so let's figure out what the radius is. All right, the surface area is nothing more than 144 pi. You could see right here, so we substitute that in here. And that is 4 pi r squared. Let's divide by 4 pi on both sides. So this cancels out. So we end up with, okay, 144 divided by 4, I think I can do it. I'm gonna try 144 divided by 4 is 36. So this is 36. The pi's go out. And that is equal to r squared. But I don't want r squared, I want r. Okay, so I have to take the square root of that. So r equals 6. Now, I'm taking the square root. So the radius is 6. Now I can go back to my volume formula and just substitute everything. All right, cool then. So volume equals to 4 over 3 times pi times the radius. Sorry, the radius is 6 times the radius, okay? And it says to the third power. Cool then. So all I gotta do now is just plug it into the calculator. So you want a fraction, so press alpha y equals, okay? And now put 4 over 3. All right, just the way I'm doing it right now, 4 over 3, okay? Move over. And we do pi, and then times r, which is 6, to the third power. So to raise something to the power, right, you press this key right here, boom, to the, and you see that, third power. And that gives me 904.77. Oh my God, I forgot something. They want it in terms of pi. Oh, okay, so if they just want it in terms of pi, I just need to multiply the numbers. So 6 to the third is 216. Okay, 216. And now when I multiply it by 4/3, okay, times alpha y equals fraction 4/3, then I get 288. So this is the volume is 288, and since I didn't utilize pi, then because I wanted to leave it in terms of pi, then this is pi. All right, so that's the volume. So the answer is choice number 4. There you go. All right, the next question. The volume in cubic centimeters of a sphere whose diameter is 6 centimeters is. All right, they want the volume of a sphere. How do I find the volume of a sphere? Well, it's 4/3 pi r to the third. All right, the diameter is 6, so the radius is 3, so that's it. That's all I gotta do. Volume equals to 4/3 times pi times r. If diameter is 6, the radius is 3, and that is to the third power. All right, so I know that 3 to the third power is 27, because 3 times 3 times 3 is 27. All right, look at the choices. They are all in terms of pi. So that means that I just have to multiply the numbers. All right, cool then. So I have volume equals to 4 over 3 times pi times 927. Okay, 27. Now, if I simplify this, I have 27 times 4 divided by 3, or 27 divided by 3 times 4. So I'm not using the calculator. 27 divided by 3 is 9. Okay, 27 divided by 3 is 9. So this number is 9. Times 4 is 36. Okay, and then the pi. So the answer is 36 pi. Whew. Good, right? All right. So let's move on to the next problem. All right. So it says, a sphere has a diameter of 18 meters, okay? Find the volume of the sphere in cubic meters in terms of pi. All right. So the volume is nothing more than 4 over 3 pi r to the third. All right. So then I have a volume being 4 over 3 pi times diameter is 18, so the radius is 9. Am I correct? Okay, so 4 times 9 to the third. Okay, and that is, oh, in terms of pi, okay. So not a problem. 9 times 3, 9 to the third power is that times fraction, okay, times 4 over 3, that is 972. So this is 972 pi. Make sense? All right, then let's move on. Okay, Tim. Tim is going to paint a wooden sphere that has a diameter of 12 inches. All right, a sphere. So I don't know how to draw a sphere. I'm gonna do my best. I really don't know. So I think it's something like this, and then you go like this, like this, like this, then like this, then like this, right? Something like that. All right. Anyway, so the diameter is 12. So this is 12. All right. Find the surface area of the sphere to the nearest square inch. Okay, so I need to find the surface area. That's not a problem. So how do I find the surface area of a sphere? It's 4 pi r squared. Why r squared and not to the third? Because I'm finding area. Okay. So it's 4 times pi times the radius, which is 6 squared. So I have surface area equals, okay, now it says to the nearest square inch. Oh, okay, so I can just multiply everything through. So I have, this is 36 times 4 pi. All right, so 36 times 4 pi, okay, that is 452, okay, 452.3893. Anyway, they want to the nearest square inch. Easy. So the surface area is 452. Now why? Because I cannot round this 3. Oh, okay. So that's cool. Then let's do the next problem. Okay, the computer didn't understand the pi, so it put a p instead of pi, but this means pi. So it says a sphere inscribed inside a cube with edges, in other words, like a soccer ball or a basketball inside a box. So it's inscribed inside a cube with edges of 6. So this is the cube. And then you draw another one right here. Okay. I don't know how I'm gonna draw the sphere. Something like that. I really don't know. Okay. Okay. So that with edges, the cube has edges of 6 centimeters. 6, 6, 6. Well, it's a cube, so it's made out of squares. Now, what is something peculiar about this? That when they say inscribed, that means that this ball, this sphere right here, is touching the ceiling and is also touching the floor. So that means that this right here is a diameter. So this is the same size, the same height as this, the same length as this. So that means that the diameter of the sphere is 6. Therefore, the radius is 3. And basically, what do they want? They want the volume. Okay, volume of a sphere is, if I can remember, let me look at the reference sheet. The volume is 4/3 pi r to the third. Everything that is volume has to be to the third power at the beginning or at the end. So now volume is equal to 4/3 times pi times the radius, which is 3 to the third power. Okay? Cool then. So volume equals to 36 pi. As simple as that. Good? Alright then. So let me see. Quiz 37. Okay, quiz 37. Just refer back to lesson 36 and you'll be able to answer every single question in this quiz. Alright? See you till next time.